Hello students, welcome to the class. In the last class, we discussed about oscillation and waves synopsis. Regarding oscillations, we have completed the important points and the formulas. Waves, we have just started. We have discussed what do you mean by wave. Wave is nothing but it is the disturbance produced in the medium which propagates energy. That is called as a wave here. Okay. Then the necessary points related to the wave are some properties we have discussed like elasticity, inertia, right, humidity, few terms which is related to wave we have discussed. Then there are two types of wave, that is mechanical wave and non-mechanical waves. Mechanical waves are those which require medium for their propagation. Non-mechanical waves which does not require medium for their propagation. Okay, so example for mechanical, non-mechanical wave we have discussed. Then transverse waves and longitudinal waves. So transverse waves, the wave motion and the particle motion, if they are parallel to each other, then it is called as transverse wave. If the wave motion and the particle motion are perpendicular to each other, then it is called as what? Longitudinal wave. Okay. Then the expression for sound of transverse wave, the equation is given by V is equal to under root of T divided by M, where T is the tension in the string and M is the linear density of the particle. Then velocity of sound in elastic medium is given by V is equal to root of E divided by rho, where E is elasticity of the medium. Okay. Then next. So Newton's formula we have discussed. Newton's formula will give the velocity of light in air. Here, if you do the calculation by using this formula, the velocity of sound, not air, that velocity of sound in air, it is found to be just 279 meter per second, which is not exactly same as that of our standard value. So therefore, Laplace will give his correction, and according to his correction, he will take a correction factor of gamma into rho. That is adiabatic elasticity he will consider. By using that, if you do the calculation, the value is found to be, the velocity of sound in air is found to be 331.3 meter per second. So this is what Laplace correction for velocity of sound in air, which is almost it is equal to the practical, that is standard value. Then next, effect of density. So what happens to the effect of density? You can see the equation that is given by V is equal to under root of gamma into P divided by rho. So here we can see that velocity is inversely proportional to what? It is square root of density. So this relation is very, very important here. The next, effect of pressure. So what is the effect of pressure on air, on sound? Here you can see the pressure equation and the velocity equation. V is equal to, it is under root of gamma P divided by rho, which is equal to gamma into RT divided by M. Okay, the velocity of sound is independent of the pressure of gas, provided the temperature remains constant. So P is equal to, or P is proportional to density when T is constant. Okay, then effect of temperature we have. The effect of temperature is given by under root of gamma R into T divided by M. So this V is proportional to root of T. It is proportional to root of T here. So when the temperature change is small, then the equation is given by Vt is equal to V naught into bracket 1 plus alpha. Vt is equal to V naught into bracket 1 plus alpha is what? The expression for velocity of sound at temperature T. So velocity of sound at 0 degree Celsius is given by V naught. T is the velocity of sound at T degree Celsius. Alpha is the temperature coefficient. Okay. The value of alpha is constant and the value is 0.61 meter per second per degree Celsius. This is temperature coefficient value. So temperature coefficient of velocity of sound, it is defined as the change in the velocity of sound when the temperature changes by 1 degree Celsius. When the temperature changes by 1 degree Celsius, then it is called as what? Temperature coefficient. Okay. Next. So what is the effect of humidity? See here. With increase in the humidity, the density of the air decreases. So when the density of the air decreases, just now you have seen the relation between density and the velocity. It is inversely proportional to square root of density. So with the rise in humidity, velocity of sound increases. As the density decreases, the velocity of sound increases. So here you can see that humidity and the velocity of the sound is directly proportional. This is why sound travels faster in humid air than in dry air at the same temperature. Then the relation between velocity of sound and root mean square velocity. So see here, that is velocity of sound is equal to under root of gamma r into t divided by m, and velocity of sound for root mean square velocity is equal to, it is under root of 3 RT divided by M. If you take the ratio of this VRMS to the V of sound, it is equal to root of 3 divided by gamma. Therefore, V of sound is equal to under root of gamma by 3 under root, or we can also write it as to the power of 1 by 2 into VRMS. So this is the relation between, that is velocity of sound to root mean square velocity in terms of adiabatic constant gamma here, right? There is no atmosphere on moon, therefore propagation of sound is not possible there. To do conversation on moon, the astronauts uses an instrument which can transmit and detect electromagnetic waves. So if there is no atmosphere, then sound will not travel, because sound is a non-mechanical, it is a mechanical wave which require medium for its propagation. So astronauts and all, what they will use? They will use some instrument to transmit and detect the electromagnetic waves here. Okay. Then next we have the progressive wave. So progressive wave means what? These are the waves propagate in the forward direction of medium with a finite velocity. Okay, so it will be in the forward direction. The energy and the momentum are transmitted in the direction of propagation of waves without actual transmission of matter. So here energy and momentum are transmitted in the direction of propagation of waves without the actual transmission of the matter here. Means the matter will not move, without that only the energy and momentum are transferred. That is called as what? Progressive wave here. Okay, next. In progressive waves, equal changes in pressure and density occurs at all points of medium. Equal changes of pressure and density occurs at all. It will be equal. Okay, then next. So principle of superposition. So principle of superposition is nothing but the displacement at any time due to any number of waves meeting simultaneously at a point in a medium. It is the vector sum of the individual displacements due each one of the waves at the point at the same time here. So if y1, y2, y3 are the displacements at a particular time at a particular position due to individual waves, then the resultant displacement is given by y is equal to y1 plus y2 plus and so on up to yn. So this is what principle of superposition means. If the waves are having the displacement y1, y2, y3 so on up to yn, then the resultant is given by y1 plus y2 plus y3 plus and so on. Right? Standing waves on a string. So when a string under tension is set into vibration, you can see in the picture, when the string is attached at the two ends, So when the tension is set inside in between that, the transverse harmonic waves propagate along its length. So transverse harmonic wave will propagate along its length. When the length of string is fixed, reflected wave will also exist. So when the length of the string is fixed here, when the length of the string is fixed, it is not moving, then the reflected waves will also exist. The incident and the reflected waves will superimpose to produce transverse stationary waves in a string. So here what happens, the incident and the reflected waves will superimpose to produce transverse stationary waves in a string here. So first normal mode of vibration is given by, that is n1 is equal to v divided by lambda 1, and that is given by v divided by 2l in terms of length. Similarly, we can also write it as n1 is equal to 1 by 2l under root of t divided by m. So this mode of vibration is called the fundamental mode, and the frequency is called as what? Fundamental frequency. The sound from the note so produced is called fundamental note, or it is also called as what? First harmonic. Then next. So second harmonic is given by n2 is equal to v divided by lambda 2 or v by l, or it can also be written as 2 into n1. So this is second harmonic, it is called as first overtone. Then second overtone or third harmonic is nothing but n2 is equal to 3n1. Okay, the position of the notes is given by 0, l by n, 2l by n, 3l by n, and so on up to l here. For the first mode of vibration, x is equal to 0, comma x is equal to l. Here only two more notes are there. For second mode of vibration, three notes will come, that is x equal to 0, l by 2 and l. For third mode of vibration, x equal to 0, l by 3, 2l by 3 and l. Okay, this is what regarding the notes. Then we have the anti-notes here. Anti-notes for first mode of vibration, it is given by one anti-note, that is L by 2. And for second vibration, it is L by 4, comma 3L by 4. That is two anti-notes will come. So progressive wave is what? It is in the forward direction. Next, let us see what do you mean by standing wave in a closed organ pipe. So you can see the figure here. Organ pipes are the musical instrument which are used for producing musical sound by blowing air into the pipe. So by blowing air into the pipe, here we can have organ pipes. So longitudinal stationary waves are formed on account of superimposition of incident and reflected longitudinal waves here. Okay. See here, the equation of standing wave is given by y is equal to 2a cos 2 pi Vt by lambda into sine 2 pi x divided by lambda. The general formula for wavelength is given by lambda is equal to 4L divided by 2n minus 1. Is 2n minus 1. The first normal mode of vibration, n1 is equal to, it is V divided by 4L. It is V divided by 4L. This is called as what? Fundamental frequency. The note so produced is called as what? Fundamental note, or it is also called as first harmonic in case of closed organ pipe. Then the second mode is given by n2 is equal to 3n. Then the third mode is given by n3 is equal to 5n1. Right? Then the position of notes are in this closed pipe, that starts from x is equal to 0, L divided by 2n minus 1. In case of open pipe, it is L divided by 2n. Then here, third is 4L divided by 2n minus 1, 6L divided by 2n minus 1, so on up to 2n L divided by 2n minus 1. For first mode of vibration, x is equal to 0, and for second mode, it is x equal to 0 and x equal to 2L by 3. For third mode, it is x equal to 0, x equal to 2L by 5, and 4L divided by 5. Then the position of antinodes are given by x is equal to L divided by 2n minus 1 and 3L divided by 2n minus 1, phi L divided by 2n minus 1, so on up to capital L. This is what position of antinodes here. Next. So this completes the synopsis of waves and oscillation chapter. Next, we have the multiple choice question. The first question is, a system exhibiting SHM must possesses. So a system which is possessing, which is exhibiting SHM, it must possess. So what it will possess? See. Options are elasticity as well as inertia, elasticity only, inertia only, elasticity, inertia, and external force. So already in the first slide, we have discussed the properties of the simple harmonic motion. In that, we know that the simple harmonic motion is it is producing it possesses elasticity, inertia, as well as external force. That is, option D is the right option here. Option D is the right option. Next. Which of the following equations does not represent a simple harmonic motion? So here they have given 4 equations. In that, which is not possessing simple harmonic motion. Let us see. So first equation is given as y is equal to a sin omega t. Second is y is equal to a cos omega t. Third is y is equal to a sin omega t plus b cos omega t. And fourth is y is equal to a tan omega t. Okay. Here, as we know that sine and cosine are the function of harmonic function. They are the function of harmonic function. But the tan is not a function of simple harmonic motion here. So the option D, that is y is equal to a tan omega t, it does not represent a simple harmonic motion as it contains tan theta or tan omega t. Only sine and cosine are the function of simple harmonic motion, not other trigonometric functions. Okay. Therefore, option D is the right option here. Next. If a hole is drilled along the diameter of the earth and a stone is dropped into it, then the stone will. So here you are making a hole along the diameter of the earth. When a stone is dropped into it, then the stone will. Then the stone will. What happens to the stone? See, reach the center of the earth and stops. Reach the opposite end and stops. Execute simple harmonic motion about the center of the earth. Reach the opposite side and escape from the earth. See, when a stone is dropped in a hole and or tunnel along the diameter of the earth, it executes a simple harmonic motion. So why it executes simple harmonic motion? Because whatever the acceleration it is experiencing, it is directly proportional to the displacement from the mean position, and it is always directed towards the center here. Here what happens? Whenever the stone is dropped into that, it will execute this SHM. Okay. Because it is accelerated with the acceleration due to gravity. That acceleration is proportional toward the displacement of the particle towards the mean position. Therefore, option C is the right option. Executes SHM about the center of the earth. Next. So there is the equation. The equation of a simple harmonic wave is given by. So you have an equation here. That is y is equal to 6 sine 2 pi into bracket 2t minus 0.1 into x, where x and y are in mm and t is in seconds. The phase difference between the two particles 2 mm apart at any instant is. So the equation is given. What they are asking you? They are asking you the phase difference here. Phase difference means angle value you need to calculate. Options are 54 degree, 78 degree, 72 degree, then 36 degree. So let us do it. So first, let us write the given equation. The given equation is what? That is y is equal to 6 sine 2 pi into bracket 2t minus 0.1 into x. This is the given equation. So I'll write it as y is equal to 6 sine into this 2 pi, I'll multiply into the bracket. It becomes 4 pi into t minus 2 into 0.1. That is 0.2 pi into x. This I'll name it as equation 1. This I'll name it as equation 1 here. Okay. Next. So next standard equation is what? Standard equation is given by y is equal to a sine omega t minus k into x. So this is the standard equation. Right now. So the path difference is given by, they asked you to calculate the phase difference, but to calculate phase difference, we require the value of path difference also. Okay, so that is given by path difference is equal to delta pi is equal to 2 pi divided by lambda into delta x. So by comparing this equation 1 and 2, equation 1 is what? The given equation. 6 sine into bracket 4 pi t minus 0.2 into pi x. And the standard equation is what? Y is equal to a sine omega t minus kx. Therefore, if you compare these two equations, we can write the value of k as, that is, k is equal to, I'll write it as 2 pi divided by, so k value is how much? It is actually, by comparing the equation, we will get it as 0.2 into pi. So this k is equal to, formula is what? K is equal to 2 pi divided by lambda. Therefore, I can calculate here lambda is equal to. So lambda is equal to, it becomes 2 pi divided by 0.2 into pi. This pi will get cancelled. So 2 divided by 0.2. 2 divided by 0.2 is nothing but that is 10 millimeter. 10 millimeter is what? Your lambda value. So the phase difference for two particles which is separated by 2 millimeter is given by, the phase difference is equal to 2 pi divided by 10, 2 pi divided by 10, that is lambda value, into delta x. Delta x value, it is given in the question, that is given as 2. So 2 5s are 2 1s are, that is nothing but, so here you are getting it as 5. 2 by 5 into pi. 2 by 5 into pi is nothing but it is 72 degree. It is 72 degree, right? So that is what? That is the phase difference is given, that is 2 millimeter. So here path difference is 72 degree. Path difference is 72 degree. What we need to do? The given equation, compare the given equation with the standard equation. By comparing that, take the value of k from the comparison, then calculate lambda is equal to, after lambda, calculate the path difference of the given equation, that is option C, 72 degree, right? Next. And then the next question is, next question. The equation describing the motion of a simple harmonic oscillator along the x-axis is given as. So one more equation is given, that is x is equal to a cos omega t plus pi. If at a time t is equal to 0, then the oscillation is at x is equal to 0. So when t is equal to 0, x is equal to 0 and moving in a negative x direction, then the phase angle pi is, so the phase angle pi is given by, that is x is equal to a cos omega t plus pi. A cos omega t plus pi. This is x is equal to. So and x is equal to 0, t is equal to 0. So when x is equal to 0, t is equal to 0, what we can write? We can write 0 is equal to cos pi. We can write it as 0 is equal to cos pi, which means that pi is equal to how much? Pi is equal to, it is pi divided by 2, right? So here the phase angle value will be pi divided by 2, that is option A is the right option. Here the condition is specified, when t is equal to 0 and x is equal to 0, then the phase angle will be, pi divided by 2, that is option A is the right option. Okay. Next question. The periodic time of a body executing SHM is 3 seconds. After how much interval from the time t is equal to 0, its displacement will be half of its amplitude. So here what they have given, the periodic time of a body executing SHM is. So the time period is given as 3 seconds. After how much interval from the time t is equal to 0, its displacement will be half of its amplitude. So when the displacement will be half of its amplitude, at what time, that we need to calculate here. See, standard equation is what? That is, it is y is equal to a sine 2 pi divided by t into t. This is the standard equation. What they have given? They have given the time period t is equal to 3 seconds. It is given as time period t is equal to 3 seconds. So when I take it as and it is given as the displacement becomes half of the amplitude. Half of the amplitude means a divided by 2. This implies in place of y, we need to substitute a divided by 2 is equal to a, I'll write as it is, sine of, it is 2 pi into t divided by capital T value is how much? It is 3. Capital T value is how much? It is 3 here, right? A will get cancelled on both the sides. So this A will get cancelled on both the side. Therefore, we will get it as 1 by 2 is equal to sine of 2 pi t divided by 3. 2 pi t divided by 3 here. Okay. So 1 divided by 2. So I can write this as sine of pi by 6. That is, pi by 6 is 30 degree, which means that 1 by 2. So sine pi by 6 is 30 degree. That is nothing but 1 by 2 is equal to sine of 2 pi t divided by 3. So sine function will get cancelled. Therefore, we will get it as pi by 6 is equal to 2 pi into t divided by 3. Therefore, we can simplify this equation. Pi will get cancelled. Therefore, now t is equal to 6 2s are 12. 3 divided by 12. So 3 divided by 12, that is equal to t. So 3 1s are 3 4s are 12. That is nothing but t is equal to, it is 1 divided by 4 seconds. That is 1 divided by 4 seconds. So the time when it is 1 by 4 second, then the amplitude becomes half of its value, and The time interval is t is equal to 0 here, right? We need to take the standard equation of SHM, then substitute the value of time period which is given in the question. That is, amplitude value is also given. Substitute both the values in the given equation. Then simplify this. So 1 by 2 is nothing but sine 30 degree. Sine 30 degree can be written as pi by 6. So after simplification, we will get t is equal to 1 divided by 4. Right? That is option C is the right option here. Next question. A 1 into 10 raised to minus 20 kg particle is vibrating with SHM with simple harmonic motion with a period of 1 into 10 raised to minus 5 seconds and a minimum speed of 1 into 10 raised to 3 meter per second. The maximum displacement of the particle is, we need to calculate the maximum displacement for the particle. So in terms of amplitude and angular speed, we have the equation for maximum displacement for the particle. It is given by maximum displacement is nothing but what? It is called as what? Amplitude. It is called as amplitude. So the equation is speed is equal to A into omega. A into omega. It is equal to omega value. It is not given. Time period is given. Therefore, I can take this omega as what? 1 2 pi divided by t, that is equal to v. Substitute the value of v here. What is the value of v? That is 1 into 10 raised to 3, the speed of the particle, which is equal to amplitude we need to calculate. So 2 pi divided by the time period, it is given as 1 into 10 raised to minus 5. 1 into 10 raised to minus 5, which implies acceleration A is equal to 10 raised to minus 5. If it goes to the numerator, it becomes in the denominator, it is there. If it goes to the other side, it comes in the multiplication. So 10 raised to 3, 10 raised to minus 5 can be written as 10 raised to minus 2. That is nothing but 10 raised to minus 2 divided by 2 pi. That is acceleration is equal to 10 raised to minus 2 divided by 2 pi. And if you simplify this, you will get it as 1.59 mm. 1.59 mm millimeter. That is option A is the right option here. Option A is the right option. So V is equal to A omega is the relation between speed, amplitude and angular frequency. Then the next question is, a particle starts SHM from the mean position. Its amplitude A and time period T. Its amplitude is A and time period is T. At the time when its speed is half of the maximum speed, its displacement Y is given by. So what they have given, a particle starts from simple harmonic motion from the mean position. Okay, that time the amplitude is A and the time period is T. At the time when its speed is half of the maximum speed, then its displacement value will be. So same formula which we used in the previous one, that is V is equal to omega into A, that is omega V is equal to amplitude in the time period. At what time? When it's what is that? Speed is half of the maximum speed. That is nothing but divided by 2. But we also know that V is equal to omega under root of a square minus y square. A square minus y square here, right? So substitute the value of V in this equation, that is given by omega A divided by 2 is equal to omega under root of a square minus y square. So omega will get cancelled here. So squaring on both the side, what we will get squaring on both the side? We will get it as a square divided by 4 is equal to, it is a square minus y square. A square minus y square here. We need to calculate the displacement. So simplify this equation for displacement is equal to what I can write here? I can write it as y square is equal to a square by 4 minus, sorry, this y square minus it is there. If it goes to the other side, it becomes plus. So here it will be a square. One second. Here it will be a square minus a square divided by 4. That is nothing but 3a square divided by 4. 3a square divided by 4. Therefore, y is equal to what we can write? Square root of this value. That is nothing but a divided by 2 into root 3. A divided by root 2 into 3. That is option C is the right option. Option C is the right option. A divided by root 3. 8 by 2 into root 3. Okay. Next question. A simple harmonic oscillator has an amplitude A and time period T. The time required by it to travel from x is equal to A to x is equal to A by 2 is. So here we need to calculate the time required to travel from A to A by 2 for the simple harmonic oscillator. Okay. So we have the equation as it starts from the extreme position. SHM starts from extreme position. Okay. So we have x is equal to, it is a cos omega t. X is equal to a cos omega t. They have given that x is equal to a to x is equal to a by 2. Here I'll just take it as a by 2 is equal to a into cos omega t. This is equal to, I'll write it as a cos omega value is 2 pi divided by t into small p, right? Therefore, it is equal to cos 2 pi into t divided by t is equal to a will get cancelled, you will get it as 1 by 2. So this is nothing but cos of pi by 3. Okay, so cos and cos inverse we can cancel that. Therefore, it is 2 pi t divided by t is equal to, it is pi divided by 3, which implies the value of t, the time period t is equal to, it becomes pi will get cancelled, 3 2s are 6, that is nothing but t divided by 6, that is nothing but t divided by 6 here, that is option A is the right option. Option A is the right option. Right? Next question. A mass m is equal to 100 gram is attached at the end of a light spring which oscillates on a frictionless surface, which oscillates on a frictionless horizontal table with an amplitude equal to 0.16 meter and time period is equal to 2 seconds. So I'll repeat the question. A mass of 100 gram is attached at the end of a light spring which oscillates on a frictionless horizontal table with an amplitude which is equal to. So amplitude is given as 0.16 meter, mass is given as 100 gram, the time period is equal to 2 seconds. Initially, the mass is released from rest at t is equal to 0 and displacement x is equal to minus 0.16 meter. The expression for the displacement of the mass at any time is given by. So we want the expression for displacement is equal to. Displacement is equal to, we want the expression here. How we can do this? For horizontal motion, the standard equation is given by. So here the standard equation is x is equal to, because it is horizontal motion, therefore x is equal to, it is a cos 2 pi by t into small t. So a value is how much? Minus 0.16, t is equal to this 2 seconds. Okay, so substitute the value. This is equal to minus 0.16 into cos of 2 pi by 2 into t. So 2 will get cancelled. Therefore, we will get x is equal to minus 0.16 cos pi by, sorry, pi into t, pi into t here. That is nothing but, you can see in the given option. Option A is 0.16 cos pi into t. B is minus 0.16 cos pi t. C is plus pi and plus pi. That is option B is the right option here. Option B is the right option here. Okay. Next question. The maximum velocity of a simple harmonic motion represented by. So you have an equation for SHM. We need to calculate the maximum velocity. See, the given equation is what? That is y is equal to 3 sine 100 into t plus pi by 6. That is the given equation. Here, how to calculate the maximum velocity? Already we know the relation between amplitude, velocity and omega. By that, we can calculate this. See here, it is given by V is equal to A into omega. What is the given equation? Given equation is y is equal to 3 sine 100 into t plus pi divided by 6. So by this equation, we can calculate the value of A and omega, right? So if you see this equation with the standard equation, by comparing that, we will get omega is equal to 100 and A is equal to it is 3. So directly substitute now. The maximum velocity is equal to A is 3, omega is 100. That is nothing but 300 meter per second. That is nothing but 300 meter per second. Option A is the right option. We need to know the standard equation. We need to understand the question and solve it. Next. A body is executing simple harmonic motion with an angular frequency is given 2 radian per second. The velocity of the body at 20 mm displacement, 20 millimeter displacement, when the amplitude of motion is 60 mm is. So here the angular frequency is given as 2 radian per second. The velocity of the body is given as 20 millimeter and the amplitude is given as 60 millimeter. They have given displacement as 20. Velocity we need to calculate when displacement is 20. So frequency, displacement and amplitude is the given data. We need to calculate the velocity. So we have a equation V is equal to omega under root of a square minus y square. So omega value it is given. There is angular frequency is mentioned as how much? It is 2 under root of a amplitude. Amplitude is how much? It is 60. So we can write it as 60 whole square minus y value, that is displacement value. Displacement value is how much? It is 20 whole square. It is 20 whole square. So 60 square is how much? 60 square is, it is 3600 minus 4000. So if you do this and take the square root and multiply by 2, we will get it as 113 millimeter per second. All the options are given in terms of millimeter. So here we will get it as 113 millimeter per second. That is option D is the correct option. Option D is the correct option. Next question. A particle executes SHM with an amplitude of 4 centimeter. At the mean position, the velocity of the particle is 10 centimeter per second. So, amplitude is given as 4 centimeter. Then the velocity of the particle is given as 10 centimeter per second. The distance of the particle from the mean position when the speed becomes 5 centimeter per second. We need to calculate the displacement, or we can say it as distance. Displacement we need to calculate when the speed becomes 5 centimeter per second and the velocity is 10 centimeter per second and the amplitude is 4 centimeter. So the distance can be calculated it as V is equal to, it is given as 10 centimeter per second. But we also know that this V is nothing but it is A into omega. So this implies, can I calculate the value of omega from this? Omega is equal to, it is 10 divided by A value. A value how much it is given in the question? Amplitude is given as 4. That is 10 divided by 4 is what your omega value. Okay. Then next we have the equation V is equal to omega under root of a square minus y square. Squaring this equation on both the sides, it becomes V square is equal to omega square into bracket a square minus omega square. So what we need to calculate here, students? We need to calculate the value of distance, that is y is equal to, therefore we can take it as, so transfer this omega square to the other side, it becomes V square divided by omega square is equal to, it is a square minus y square. So we want only y square is equal to. So y square I'll transfer, therefore I'll get it as y square is equal to, it becomes a square minus V square divided by omega square. Therefore y is equal to under root of a square minus V square by omega square. So now we can substitute all the values and we can calculate it as, this is equal to under root of a square value, amplitude is 4 square, it is 4 square minus V value is 10 divided by omega value is 10 by 4. Omega value is 10 by 4. So this speed it is given as 5. Sorry, this is given as 5. So here it is 10 by 4. This entire whole square. Okay, so if I simplify this one, then I'll get it as 2 root 3 centimeter. 2 root 3 centimeter. That is option C is the right option. We have the formula V is equal to this one. V is equal to omega root of A square minus Y square. In this equation, calculate the value of Y. To calculate the value of Y, we require the value of omega. Just calculate the value of omega by using this relation, right? 2 root 3 option C is the correct option here. Next question. Which one of the following equations of motion represents simple harmonic motion? So which equation represents simple harmonic motion? Let us see that. See here in the given equation in which the acceleration is proportional to displacement and it is towards the mean position. Let us see that. See, option A is what? It is acceleration is equal to minus k naught x plus k1 x square. B is acceleration is equal to minus k into bracket x plus a. Option C is what? Acceleration is equal to k into bracket x plus a. Option D is acceleration is equal to kx, where k naught, k1 and a are all positive. They have given that all the values are positive. So here in the given all equations, equation 2, that is option B, acceleration is equal to minus k into bracket x plus a represents the SHM. Why? Because here in this case, the acceleration is proportional to our displacement of the body, and that negative sign indicates it is towards the mean position. Therefore, option B is the right option here. Option B is the right option. Then the next question is, a simple pendulum is suspended from the ceiling of a lift. When the lift is at rest, its time period is T. So here a simple pendulum is suspended from the ceiling, right? Then with what acceleration should the lift be accelerated upwards in order to reduce the period to T divided by 2? So in up to what height it should be raised so that the time period becomes half of its value, that is T divided by 2. That is, time period of a simple pendulum is given by T is equal to 2 pi root of L divided by G, and T dash is equal to, I'll write it as T divided by 2 because the time should reduce to half of its value. Now, what they are saying here, according to the question, we will take one small figure. See this. So first let us prove this one. What we have taken, this is that T dash is equal to 2 pi divided by 2 because T dash is equal to T by 2 it is. Therefore, it becomes 2 pi divided by 2 into root of L divided by G. That is nothing but 2 pi under root of L divided by 4G. L divided by 4G. This 2 I am taking inside the square bracket. The lift should be accelerated. Here the lift should be accelerated by 3G upwards because the total acceleration is G plus 3G. Here this 4G can be written as what? G plus 3G. Right? That is nothing but pseudo acceleration. Means suppose here if you take this point from down, it is G, and upward it is 3g. Therefore, total it becomes g plus 3g, that is 4g. That is option D is the correct option. That is, it should accelerate with 3g so that the time period becomes half of its value. The time period becomes half of its value. Option D is the right option here. So it is also called as pseudo acceleration. Okay. Then one more question for today's class. The amplitude of a particle executing SHM with a frequency of 60 Hertz is 0.01 meter. So they have given the frequency and the amplitude is given. The maximum value of acceleration of the particle we need to calculate here. Okay, the maximum value of acceleration is given by acceleration is given by maximum acceleration is equal to, it is A omega square, where omega can be written as 2 pi into f. This is equal to A into bracket omega is 2 pi f, that is 2 pi f whole square, that is nothing but A into bracket 2 square is 4, it is pi square into f square, that is equal to amplitude is 0.01 into 4 into pi value. So answer options are given in terms of pi, therefore this pi I'll keep as it is, pi square into f square. F value is frequency, the 60 whole square. That is nothing but, so that is 0.01 into 4, 0.04. 0.04 into 60 whole square. That is nothing but, after simplification, you will get it as 144 pi square meter per second square. By meter per second square, as it is acceleration, calculation, it is written as 144 pi square meter per second square. That is option A. Here, students, you can see option B is given as only 144. That is not right. Option A is correct here. Why? Because we want answer in terms of pi square. Suppose here if it is not given pi square answer, then we can go for option B also. Okay. No, suppose if you substitute the value of pi, then option B will not come. Option A is the correct option. Again, if the pi value is substituted, you will get some different answer here, right? Okay. So in the next class, let us continue with the few more questions. Thank you, students.